Okay, so last time we talked about if we had a box, taking the corner to corner distance and finding the angles. So today we're going to talk just a little more specific about actually doing drilling. So if I have a block, oh, nice to see my computer's working well this morning. So let's say if I have a block that I'm looking at from the top, I'm going to bore a hole that starts right there on the top. It goes in there. And on the bottom, it's going to come out here. So we have a path of the bore like that. Now, because that's three-dimensional, it's hard to define. So what we're going to do to simplify it is we're just going to define the center line of that bore. And we can think of the center line of that bore basically back to what we were looking at as that box from yesterday. Because we're going to have, we're looking at from the top, of course, we're going to have a length here. That would be the length of our box. This was just the width of our box from yesterday. And then, of course, there's a thickness of the material, which was the height or the thickness from yesterday. So once again, all we have to look at is one of these. So let's, we're going to be looking at the path from here to here. And if we are told that this offset is 3/4 of an inch and that this offset is a 1/2 inch, and the thickness of our material is a 1 inch thick, then over here, of course, this is 1 inch, this is 0.5, this is 0.75. We can go ahead and do all of our calculations from yesterday. So I can find, and of course, what we're going to be looking at is we're going to look at an angle of rotation. Because remember, we're talking about that platform on the drill press. How far do we have to rotate it? Well, what we're really looking at is from some sort of an imaginary line here, there's going to be an angle of rotation here. Well, that angle there ends up being the same as this angle right here. So that is going to be our angle of rotation right there. And just like we did yesterday, our angle of tilt is going to be this angle up here. The way I drew that today, you don't get to see that very much in the 3D view, but you guys can imagine what I'm talking about. It's the angle between this upright here and then this corner-to-corner diagonal that I drew in. So for this box, let's find those measurements. And then what I'm going to do is I'm going to show you some formulas for them that kind of come from the measurements we're going to take anyway. But the first thing we're going to do is we're going to find the length of the bore. The length of that bore is going to be found by doing what? Not everybody wants. Yeah, pi. Careful.
Square root of each of the dimensions.
Oh, your square root of 0.75 squared. 0.5 squared plus 1 squared. Okay, good. So we can just punch that in. Second square root. 0.75 squared plus 0.5 squared plus 1 squared is 1.346 inches. So that's the length of our bore. Next, to find R here, we're going to be using, you got it, an inverse tangent. We're going to be using that triangle. Here's a triangle. Here's R. This is our length. This is our width. Notice I'm using the capital L there for length and the script L for the length of the bore. And of course, this is 0.75 and this is 0.5. So R is the inverse tangent of 0.5 over 0.75. You got it. giving us 33.69 degrees. And then our angle of tilt, this is our depth here, our thickness. I'll write it as depth, because T is already angle of tilt, so we'll do depth. And this is the length of our bore here. We could find the length of this base here, but that's a calculation we don't need for anything else, so why waste our time? This depth, of course, is 1 inch. And this we calculated to be 1.346. And here's our angle T. How do we find T? Inverse cosine of 1 over 1.346. So second cosine 1 divided by 1.346. Excuse me. 42.017. 42.02 we're going to call it. Degrees. So we found our angles there. Well, how could we have found them with just some straight up formulas? Well, right up here. This was pretty simple. That is just, our rotation is simply the inverse tangent of our width divided by our length. Pure and simple. Our angle of tilt, now the book's going to give you a different formula, and I'll show you that one in just a second. Our angle of tilt, we've used the inverse cosine of our thickness, or our depth, divided by our length of bore. To me, that's the easiest formula to use, because we need that length of bore if we're going to do cutting times and stuff like that, drilling times and stuff like that. We need the length of the bore anyway. Now, the other way to do it, going back to this triangle here, is you know that this is the depth here, this is that D we'll call it. They could find this length across the bottom. That length was just going to be the square root of the length squared plus the width squared. Remember, just the bottom dimensions of the box. That's that distance across corner to corner. So the way the book defines this angle T is it defines T as the inverse tangent of the square root of L squared plus W squared over D. To me, if you want to use that, that's fine. But to me, this is something you don't need to calculate, so why waste your time? This one's simpler anyway. Once you have that length of the bore, it's right there. I want you guys to try one. In the packet I gave you yesterday, page 395, I want you to try number 1. Let's see how that turns out. What'd you get for the angle of rotation? What is it? 38.37. Do you guys concur? 38.36. Okay, well, we'll live with that. Angle of tilt? Yours is wrong? 49.66. Do you guys concur?
I got 6.5.
6.5. Oh no.
4. Huh?
6.4.
I got 6.5, but
Yours is wrong. Okay, well, the good news is, I want you guys, we're done with listening to me. The bad news is, on page 395 through 397, let's have you continue and do 3 through 9 the odds. Which is only, what, 4 more problems, so not that harsh.